Relations and functions. Now, before we start talking about relations and functions, we need to cover a lot of vocabulary terms. The first one is, what is a relation? A relation is just a set of ordered pairs. Okay, now, the domain is going to be the set of input values, or your x values. The range is a set of output values, or your y values. I always do it like alphabetical order. When we're looking at a coordinate plane, we go x, y. Okay? X comes before y in alphabetical order. So when we're looking at domain and range, you're going to do it in alphabetical order. Domain comes before range, so domain goes with x and range goes with y. Now a function is a relation that assigns exactly one value in the range, or the y value, to each value in the domain, which is the x value. One x value doesn't have two y values. Each x has only one y value. So, a function rule is an equation that describes a function. And then function notation is when you use this f parentheses x to describe the outputs. It's basically a little bit of a fancy way to write y equals, or just to say this is the rule of the function. A lot of times we'll read it as f of x, which means a function of x is what the f of x kind of means. Or f is a function of x. Now, let's look at the ways we can determine whether a relation is a function. The first way is our vertical line test. I think this is the easiest way. If any vertical line passes through more than one point of the graph, the relation is not a function. Remember, a vertical line goes up and down, just like that. So we're going to be doing a lot of those vertical lines. Now the second way is a mapping diagram. This is where the domains, which is, remember, x values, must all be different numbers, but the range values, or the y values, can be the same for the relationship to be a function. Okay, let's look at actually doing the mapping diagrams and vertical line tests. So the first thing I want to do is I give you this right here, a set of ordered pairs, which is a relation, and I want to know the domain and range of it. All I'm going to do is write out the numbers that are the x values and the numbers that are the y values. That's it. So my domain for this, and of course I'm using my brackets, is going to be all the x values. So it's going to be 1, -4, 3, 0, and 2. All I have to do is write them all out right here. Okay? My range are my y values. That's 3, 0, 1, 4, and 3. Notice I have 3 written both. 2 3's going to 2 places. I only have to write it once. You don't need to write a 3 a second time for the range. So notice I don't even have to put them in order from least to greatest or greatest to least. I just list my values. Okay, let's look at this second one. We have the set of ordered pairs, which is a relation. I'm going to state my domain, my x values. So it's 2, -2, 2, -2, and 3. Notice my 2's repeat, and I got 2 -2's. I only have to write it once. Okay, so here's my domain, 2, -2, and 3. My range is going to be -3, 3, 3, -3, -2. I have 2 3's and 2 -3's, so I only need to write it once. So my range is -3, 3, and -2. And that's all it's asking when it's asking what's the domain and range. Alright, now we're going to determine whether each relation is a function down here. I give you a set of ordered pairs, which is the relation, and we're going to find out if it's a function by doing the mapping diagram. Now, mapping diagram is this. You list your x values, you list your y values, just like I did here. 6, 5, 2, and 12. Okay? Now I list my y values. 3, -2, 3, which I don't have to write it again, it's right there, and -12. Now, I draw a line from my x value to the corresponding y value. So here's a pair, 6, 3. I draw an arrow from 6 to this 3. Then I have 5, -2. Draw an arrow from 5 to -2. Then over here I have 2 3's, so draw an arrow from 2 all the way up here to this 3. Then I have 12, -12, so draw an arrow from 12 to -12. Now to determine if it's a function or not, look at your x values. Do you have more than one line coming off of that number? And no, each one of these x values has one line and one line only coming off of it going to a y value. So this is a function. I'm okay to have two x values going to the same y, but I'm not okay if two x values or an x value is going to two different y's. Alright, let's look at this fourth one. So I list my x values, so it's 3, 2, 1, and I have a second 3 so I don't have to write it again. Then I have my y values, 7, 5, 6, and -5, and I've written those there. Now draw my lines. 3 goes to 7, so I'm going to draw here to here. 2 goes to 5, so here to here. 1 goes to 6, so here to here. And 3 to -5, so I go from here down. Notice, on this example, this 3 right here has two lines coming off of it. It goes to two different y's. Since this happens, this one is not a function. It's just going to be a relation, but it's not going to be a function. Notice this one, each x value had one arrow coming off of it, so it's a function. This one, the 3, had two arrows, so it's not a function. Alright, let's look at the vertical line test. Now the vertical line test is exactly what it says. Draw your vertical lines. So let's look at this one, number 1. If I draw vertical lines, and I literally mean vertical lines, just like this, notice my pink line here is my relation. Each time one of these comes, it hits it only once. So this line hits it once, that line hits it once. Each line only hits the vertical line or the function once. So this is going to be a function. Alright, let's look at 2. Let's draw vertical lines. Vertical lines. Alright, notice these two lines don't hit it at all. That's fine, doesn't have to. But notice these 3 lines hit it both there and there. They hit it, the function or the relation twice on one vertical line. Because of that, this one is not a function. Remember, you only want it to hit once or not at all. Okay, let's look at number 3. Now, I've got this crazy looking line. Let's do vertical lines. Alright, well, it looks like that hits it once, that one hits it once, that one hits it once. Well, that one hits that whole line there. 1, 1, 1. But because this line right here goes through this entire point right there, basically lies flat on that line part, this is not going to be a function just because of that little spot. So this one is not a function. Alright, this relation, I have little dots going everywhere. But that can still be a function. Let's do the vertical line test. So, drawing my vertical lines. Okay, if I continue to draw, notice each vertical line has one or less dots on them except for right here. That vertical line has 2 dots on it. So that, because of it, is not going to be a function. Just because of that little line is what makes it not a function. There's 2 dots going through it. Alright, now we're going to evaluate function rules. Remember when we were evaluating expressions and all we did was plug in the number that we want x to be? That's exactly what this is, except written a little different way. Alright, so this first one I want to evaluate for f of n. There's a fancy function writing. Equals -3n minus 10 4n equals 6. So what it is asking me is to take this 6 and plug it in for n and solve. So I'm going to write my rule out. And then how you do the notation is this is what I'm putting in for n. So I'm going to do f and then parentheses 6. That's how I know, okay, n is going to be 6. That's why I'm plugging in right now. So I put negative 3 times 6, and notice I do parentheses because I'm putting it in for n, minus 10. Negative 3 times 6 is negative 18. Negative 18 minus 10 is negative 28. So my answer is f of 6 equals negative 28. That's it. That's all you have to do. Very easy. Okay, let's look at the second one. We're going to evaluate y equals negative 2x squared plus 7. Okay, but for x is going to equal negative 4. So I'm going to do y equals my rule. So I'm going to take y equals, I'm going to put negative 4 in for x. Remember, I put it in parentheses. So I need to do that first. Negative 4 squared is 16. 16 times negative 2 is negative 32. Then add 7, and that's negative 25. So y is going to equal negative 25, and that's my answer. Okay, this last one, we're going to evaluate g of x equals negative, or basically the opposite of x plus 2, for when x equals negative 3. So, when you have the function notation, you put in for the x what your number is going to be, so it's negative 3, g of negative 3, equals. Now, I have a negative outside of this x. Keep the negative there, put the parentheses, put what you're asking x to be in parentheses, and then close it and do the rest. So add 2. Now when I take the opposite of negative 3, that's 3. Well, 3 plus 2 is 5. So my answer is going to be 5. Alright, finding the range of function rules is exactly what we just did. So they'll give you the domain, which is, remember, these are your x values. Okay, and it's asking you for the range. So all you do is plug these 3 numbers into each one of your rules, solve, and there's your domain that you're going to get, or your range, excuse me. So I have this first rule, f of x equals x minus 6. I want to plug in negative 2 first. So I do f of negative 2 equals negative 2 minus 6, which is negative 8, so that's 1. Then I do 0, so f of 0 equals 0 minus 6. 0 minus 6 is negative 6. There's my second range. Now I do f of 5 equals 5 minus 6, which is negative 1. So my range, when given this domain for this function, is negative 8, negative 6, negative 1. And that's all you have to write, is right there. Now let's do the second one, using the same values. Okay, negative 4 times negative 2 is 8, so that's one of them. Negative 4 times 0 is 0, there's your second. And negative 4 times 5 is negative 20. So, given this domain, my range is 8, 0, and negative 20. That's all you have to write. For this third one, g of x equals x squared plus 1. I'm going to plug in each one. So I'm going to do negative 2 squared plus 1. Negative 2 squared is 4. 4 plus 1 is 5. There's one of them. 0 squared plus 1. So 0 squared is 0. Plus 1 is 1. Then I do 5 squared, which is 25. And 25 plus 1 is 26. So my domain for number 3 is going to be negative 2, 0, 5. What we get out for our range, my answer is 5, 1, and 26. And that is all you have to do.